Hello all, this is Satvik from Eclipse Defender team. Our team focuses on Eclipse attack. In the last videos, we discussed about the vulnerability that we want to tackle. The vulnerability is about how both inbound and outbound slots are susceptible to an attack with constant ping pongs. Our new algorithm is about how the victim can find whether it is under attack currently. Our new algo will check the inconsistencies which the attacker induces. Our algo will be executed every 90 seconds to decrease the vulnerable conditions. Now the question of why 90 seconds? Remember, there are 17 K buckets in DST table currently, that is from 239 to 255. And the last node in the K bucket is queried for availability for every 5 seconds. So as you can see, the best case for an attacker to impact all K buckets is 85 seconds, which is 17 into 5. As the outbound slots are filled by using the function read random nodes from DST table, we need a frequency of at least 85 seconds, if not less, to detect the attack. For a round of purpose, we kept it as 90 seconds. Now coming to our algorithm, assume the victim node is filled with all inbound and outbound slots, and assume that it is under currently attack. Now the frequency of 90 seconds kicks in and we start to check the inconsistencies. Our lookup module will check the inconsistencies by finding 10 new nodes through find node request, and if inconsistency is present, suspected nodes or IPs stored in the lookup intelligence, which is the newly created buffer in this module. Check buffer is the new module created, and if more than 5 nodes say yes out of 10, then this module will return saying the inconsistencies are present and we are currently under attack. Now lookup module will send a request to the upper layers to erase all the connections and remove fillings in the tables. Now upper layer will erase all the connections as per the request, and a fresh start to the server or dev P2P will be made. Now here, the fillings in the table and the new connections will be made by checking with the intelligence that we have in the lookup module. Once the inconsistencies are cleared off completely, upper layer will trigger a channel through which it sends the intelligence that it has to its connections, thus decreasing the Eclipse attacker's frequency even further in the network. Now let us take an example, digital cat. This is discussed in tier 2 as well. This NFT example has a param x and a threshold 5. If and only if param x is less than 5, Alice will bid for the cat, or else no. Attacker will influence Alice to bid for the cat even though x is greater than 5, saying x is actually less than 5 to Alice. Now let's see how the algorithm works in this case to tackle the problem. As we say, we find 10 new nodes in the lookup module, and if 5 new nodes say x is greater than 5, then the suspected nodes are stored in the intelligence buffer in the lookup module, clears of inbound, outbound, and the tables, a fresh start is made. If now Alice finds that there are no inconsistencies, a channel will be created from the upper layers, and through this channel, Alice will share the intelligence to its connections. Every 90 seconds, Alice will invoke this algorithm to find the inconsistencies. We actually made a GIF for this new algorithm. Here we have connections to Alice, and Alice will ping 10 new nodes. And if 10 new nodes say yes, then Alice will do a fresh start and create a new connections. Suspected nodes will be stored in the lookup module, and the channel will be made and shared with the new connections. Now we want to show the pseudocodes that we made. Check buffer function is actually used to check the inconsistencies along with the lookup inconsistency function. A reboot variable is created, and if it is true, then a fresh start is made in the server or dev P2P. And the pseudocode for intelligence share we have the functions check with intelligence and send intelligence. Send intelligence function is used to send the intelligence to the connections that we have, and check with intelligence is invoked whenever a new node is added to the table. My teammate Shunon will present the simulation and application of our algorithm. Thanks for listening.
Hello, everyone. Welcome to my section. And because of the inbound and outbound slot that can recall some attack node or fake node or failure transaction history. So my idea is how to monitor this activity. And I design a Shining app through the R language. And this interface is an HTML interface. So first of all, it will have some function like the type in the what is your favorite coin, and then you can search this different icon for different crypto coin, and then generate some safety audit report based on your activity. So for example, the monitor function is like you select the Bitcoin and the Ether. For example, like the Ether coin, and then you select the attack node, and the market cap is a total transaction. So it's just a simulation attack node underneath it, the Ether code. So if more transaction I will suppose there will be more the attack, the green light underneath. So also we can also see the difficulty of this attack node. And also the other function is like to check the prices with Ether and Bitcoin. And the last function is about some crypto data reference. So through this data, we can see a lot of where it comes from and check on the market through the information. Thank you.